Okay, so our goal now is to figure out the area of one of these polar rectangles, because when we want to integrate over a region in polar coordinates, our first step is going to be to chop up the region. And so let's assume this whole region over here is my region R, this whole thing. And we would chop up this region R into a bunch of different polar subrectangles. So let's call it, let's say we'll do N by M polar subrectangles of area delta A. And now we need to figure out what is that area going to be. So notice, just using geometry, that I can, and what I'm going to do is use this little piece here to zoom in. So let's pick one little polar subrectangle from over here. Let's pick, how about that one right there in pink? And we're going to assume this is just the blown up version of that exact same polar subrectangle. So we can just zoom in and figure out how to find its area. Notice what I can do is take the area of this entire sector, which I'm just meaning like this entire piece of pizza. So let's highlight it like it's a big pizza piece. Okay, because this is an area, I'm sure it's going to come back to you pretty quick from high school that we can figure out. And then I could subtract off the area of the smaller pizza, which, let's make it, that's, oh, we need a different color. And then you'll notice I would be left with the pink area after that. Okay, so let's find that. Take a minute first and see if you can remember how to find the area of a sector, of a circle. Let's just draw a little circle and it'll flash back for us. Okay, so see if you could figure out, and I'm just writing, instead of theta, I'm writing delta theta inside there because that's what we're going to be using as we chop up this region ourselves. See if you can remember how we can figure out this area. Okay, so if you said, well, I know that the area of the entire pizza would just be pi r squared. And this is just one little slice, and I can figure out what fraction of the entire pizza this is by thinking that, well, delta theta, my theta here, is out of a total of 2 pi radians. And so this area is going to simplify to just be 1/2 r squared delta theta. So we're going to do that for both the big piece, the big piece of pizza and the smaller one. So let me write that here. And you'll notice the main thing that's going to change is what our R is. So for the big piece of pizza, we're going to use the fact that this radius right here, I'm just calling this R sub ij, the center of this whole region. So if I'd like to find the total or the radius, if I go all the way out of this big piece of pizza, I'm going to start here, and then I'm going to add this tiny little piece that I have left right there, and that is just going to be half of whatever my delta R is. So plus delta R over 2, and I'm going to square that whole thing because I need to have my radius squared. And then similarly, if I want to find the smaller radius, let's make it, let me make it a different color here. Then I'm going to do this minus delta R over 2 and then square it. So I'm going to expand this out and simplify, and we'll see exactly what the pink area is of this polar subrectangle. All right, and then just doing some algebra, we can see these terms will cancel, these terms will cancel. And so we're just going to be left with, oops, even the 1/2 is going to go away because I'm going to have 1/2 minus a negative. So I'm just going to have r sub ij, delta r, delta theta. And that is how I'll be able to figure out this area for each of these little polar subrectangles. So now let's think about if I wanted to find the total area. Okay, well, let's actually back up for a minute. We know what the total area of that large piece of pizza is, but we could also think about it in terms of a double integral, right? Because we've now found the area of any of one of these little pieces is delta A. And so if I wanted to think about it in terms of a double integral, which is going to become important when we start trying to find volumes over this region, right? So let's just think of the area of R, the whole region, which we know, we found out it was this up above, but let's think of how we could also write it in terms of a double integral. I'm going to be adding up these little delta A's, and then taking the limit as both my delta R and delta theta are going to 0, which is the same as my M and my N are going to infinity. And this is just a limit of a Riemann sum. We can recognize this. Oh, we can write this as a double integral over my region R. And my integrand now is just going to become R from this piece. This delta R will become dr in this notation, and this will become d theta. Okay, so a key thing to realize is this is the same as just integrating, just finding the area, which means in polar coordinates, dA is just r dr d theta. Okay, so let's do an example with this, and then we'll just do it with a simple area first, and then we'll actually go back to figuring out volumes and go back to that picture we started with as our warm-up. And before I forget, if you were like, why do you have two i's? One of these is a j. This is j, this is I. We're taking the limit, and we end up with the area.